The discriminant is a part of the quadratic formula which is used to solve quadratic equations. In this formula, the expression under the square root b squared minus 4ac is the discriminant. We can use the discriminant to help us determine the type of solutions a quadratic equation has without fully solving it. So if the discriminant b squared minus 4ac is positive, which is greater than 0, you can take the square root of a positive number, so that means that your quadratic equation is going to have two real rational or irrational roots. If the discriminant b squared minus 4ac is equal to 0, square root of 0 is 0, so the square root part disappears, so that means the quadratic equation is going to have only one real solution. If the discriminant is negative, which is less than 0, you cannot take the square root of a negative number in the real number system, so the solutions involve imaginary numbers. And we call that either two imaginary solutions or no real solutions. In this problem, we are going to use the discriminant to determine the type of solutions this quadratic equation has instead of fully solving it. So before you can use the formula b squared minus 4ac, we have to make sure our equation is set equal to 0. So to do that, we need to add 6x to both sides. So now my equation will be negative x squared plus 8x plus 3 equals to 0. Then we need to identify the values for a, b, and c. A is the number in front of x squared, so there's an invisible 1, so therefore a equals to negative 1. B is the number in front of x, which is 8, and c is the constant, which is 3. And now we're going to plug this into our discriminant formula, b squared minus 4 times a times c, where b is 8, a is negative 1, and c is 3. Now we're going to simplify this. A squared is 64. Negative 4 times negative 1 is 4 times 3, so that will give us positive 12. And the discriminant is going to be 76, which is positive greater than 0. So this tells us that this quadratic equation has two real solutions. And because 76 is not a perfect square root, we know that it's two real irrational roots. Here's another example of how we can use the discriminant to help us identify the type of solution. So again, the first step is to make sure the equation is set equal to 0. So for this one, I need to add ax squared on both sides. So now my equation is negative 3x squared plus ax squared is 5x squared. And then you bring the rest of terms down, and that's equal to 0. So again, I need to identify the values for a, b, and c. So a is the number in front of x squared, which is 5. B is the number in front of x, which is negative 60. And c is the constant, so that's 450. So now we're going to plug into the discriminant formula b squared minus 4 times a times c, where b is negative 60, a is 5, and then c is 450. So now we're going to simplify this. Negative 60 squared is 3600. Negative 4 times 5 is negative 20, times 450 is negative 9,000. And 3600 minus 9,000 is going to give us negative 5,400, which is less than 0, and we cannot take the square root of a negative number. So this tells us that this quadratic equation has two imaginary solutions or you can say no real solutions. Here's the last example of using the discriminant to determine the type of solution. The first step again is to make sure the equation is set equal to 0 by adding 4 to both sides. So now my equation is negative x squared minus 20x minus 100 equals to 0. Then we're going to identify the values for a, b, and c. A is the number in front of x squared, and there's an invisible 1, so therefore a equals to negative 1. B is the number in front of x, so that would be negative 20. And c is the constant, so that's negative 100. So now I'm going to plug in into the discriminant formula, which is b squared minus 4 times a times c, where b is negative 20, a is negative 1, and c is negative 100. So now I'm going to simplify this. Negative 20 squared is 400. Negative 4 times negative 1 is 4 times negative 100. That will give us negative 400. And 400 minus 400 equals to 0. Because our discriminant equals to 0, we know that this quadratic equation only has one real solution.